We're here today to talk about working with databases and Groovy. If you're interested in the examples and slides for this talk, they'll all be on SlideShare and GitHub. If you do a Google search on my name, you'll see my sites there, which I've got most of my talks on. I haven't pushed the latest version. I've just been tweaking my slides in the last few minutes before the talk. So I'll push it up again straight after the talk if you want the latest versions of everything. What are we going to talk about today? We're going to talk about a SQL library, a SQL API, if you like, that's built into Groovy in the class package groovy.sql.sql. It's basically a helper library that sits above JDBC. So that's the first thing we'll have a look at. We'll then have a brief look at datasets, which adds even more value on top of SQL. We'll briefly look at MongoDB and Neo4j as well, which are some different flavors of database that your organizations might be starting to make use of at the moment. So groovy.sql.sql, and I find the class name a very strange name, but it's now a legacy of early days of Groovy, and we're kind of stuck with it for the time being. It's basically pointed to a database. It is one that, like JDBC, exposes to all the way through to programmers the actual SQL queries, which is why it's got its name in that form. Now you can actually, although you'll mostly want to use the SQL class with Groovy, its API is designed so that you can use most of the bits of it from Java as well. So if you're stuck using Java, you can dive in and get a little bit of value add out of this SQL class as well. Okay. So if you're already familiar with the JDBC API, you can leverage all of your knowledge, and you're just going to have a friendlier syntax sitting on top of that lets you make use of it nice and easily. Let's have a look at how we get started. So the first thing you'll need to do is create yourself an instance of this class. And so you can either use the constructor, which we'll get to in a minute. Most people will use as a factory method SQL.newInstance. And this is what we're going to use here. And often when you're dealing with databases, you'll be quite familiar with the information that you need to pass it. You need to pass it things like a driver that you might be using, things like the URL, which will be an encoded form for which particular database you want to talk to. So if you've ever used JDBC, you will have seen stuff like this. You'll have seen driver class names, and usernames and passwords and things like that will also be typically the kind of information that you can pass through. I think there's about 7 variants of this overloaded versions of this method. So if you've already loaded a default driver, you can leave this out. If you don't have authorization turned on, and why don't you? But if you don't, you could leave these out and so on. So there's a few different variants. I'll show you one more variant on the next slide. So you'll create this new instance, then you'll use it, which is what we're going to talk about on the next 10 or so slides, or 20 slides, and then you'll just close it off. Okay? This particular snippet of code is assuming that the driver is on the class path. I'll show you a couple of variants if you don't have that on the class path. Does that all make sense? It's pretty straightforward so far. Yes, question? If you get all that in the data source.groovy, can you just use the default constructor? Yes. In fact, the next slide will show us a typical thing. So there's going to be a few cases where you won't use this particular factory method, and the next slide will show us what they are. No, it won't. It's a slide after, sorry. We'll come back to your question in 2 slides' time. So just some variations. If you don't, so I said in the previous slide, we're assuming that the driver that you need is on your class path. Okay, now you might not want to embed, have that assumption. So you might want a fully embedded script that you can just pass to someone and it'll download whatever drivers are needed. If you need to do that, just have a self-contained script. So you're not using a build file, an IDE where you'd go and install it, or a Gradle, or an Ant, or Maven build file. Then you can put grab, which is one of the annotations that's in Groovy, put in a URL, a Maven repository URL, or an Ivy repository URL, and there's a little bit of magic you need to do here. System class loader equals true. Groovy's got I was going to say sophisticated, but it actually tries to not be too sophisticated, it's got a class loading hierarchy, and the way Groovy tries to stay out of forcing a particular class loader regiment on you, because you might be running inside an application server, you might be running on Android, you might be running on a standard desktop environment. So Groovy tries to say hands off, we'll let someone else take care of the class loading issues, but Groovy's smart enough that it'll self-contain scripts that you write in their own class loader. It'll do the appropriate things. The only tricky bit is if you are going to use a driver which is referring back to some SQL classes that are in a root loader, it's not going to find them. So you put this little bit of extra information in here, system class loader equals true, and that'll make sure that the drivers that are getting downloaded get put in the right place so that the SQL driver manager can find them and see them, and the driver you load will be able to see back to the SQL classes. So that's just a little bit of trick you can put up if you want to have a self-contained script. So probably not needed for production code where you'll have everything inside a build file, but it's very, very handy for self-contained scripts. We've used this technique in some of the organizations we've worked with, been very, very agile, and they've come from a very, very non-agile background, and they had DBAs who will tell you that, no, I've gone and set the database up exactly as you want. You can actually email them a little script that is fully self-contained. We've set them up previously with a Groovy console. They can cut and paste the script, run something in it. It'll show on their screen, no, you don't have permissions to use the database, or whatever it is that we're complaining about, and they'll know straight away, oh, I forgot to tweak this for you, I'll go do that for you. So having self-contained scripts is really, really handy when you need it. Now, one of the other, I said there's about 7 variants of new instances, of the new instance factory method. Here's another variant. You can take a map. And so the 4 bits of information that I passed in before, if I don't want to have to remember what order are these in and so forth, obviously if I've got an IDE, I'll get completion. But if I'm in a text editor or something, I might not want to have to remember what the order is. I can just use the name, Groovy's named parameter variation, pass that same information in, and it'll get passed through. The nice thing about the map variant is all the other setters and getters that you'll see in the SQL class, if you go and look up the Java doc, there's a set cache statements. You can set to a Boolean value true. There's a set result set concurrency, and there's a set of integer values that you can feed into that in the result set class. All of those can be fed in the same way, and this information can be stored in a properties file or whatever it might be. Anything that can be turned into a map-like structure. That's kind of handy. The other thing that Groovy's emphasizes quite often is using closures to do snippets of code that clean up after themselves. So in the earlier slide, I showed you the SQL.close. You'll probably find I don't show that much in most of the rest of the slides. I won't show much of the getting started stuff in each of the rest of the slides, otherwise I won't fit much on the slide. A lot of people forget the SQL.close altogether, and if you're using a in-memory database like I'm using here, you'll probably get away with it, but you don't want to be locking database connections and causing yourself grief by running out of connections and having to scream at those the DBAs when it's your fault for not closing. So the nice thing about the with instance instead of the new instance, again, there's about 7 variations of that take all the map flavors, all the different parameter flavors. After you've finished your little snippets of code here, it'll just close automatically. Right? So you can't forget to clean up after yourself. So that's a nice little variation you might want. Now, going back to our earlier question, the other main way that you'll use create yourself a SQL instance will be if you have an existing data source. So you could have a data source, or you might have an existing connection that you've manually pulled out of a connection pool or something, or you might have a SQL, if you've already got a SQL instance and you want to create another one based on the information you've already fed it, you can create one of those as well. Okay, so here, instead of using a factory method, you'll go new SQL, and you can either pass in a connection or a data source at this point, or a SQL. Right? And this particular one here is using the JDBC driver I was using on the earlier slide. It's just an in-memory database. There's a whole bunch of them around. You can pick a different one. Actually, I should mention that as well. If you go and use a different database library, and you'll be familiar with this concept if you know any JDBC, you can just go and change the URL format. That typically changes, change the driver. Maybe this information may not change. And all your other stuff will, apart from the caveats I'm going to tell you about later, such as stored procedures and a few other little bits and DDLs, all the stuff that's in here will remain unchanged. That's not really a Groovy feature, that's just piggybacking on JDBC's ability to do that. So just in case you weren't already familiar with that notion out of JDBC. Okay, so we can, this particular driver has a built-in data source functionality built into it, and it's got a constructor that you just pass in the same kind of information we saw before, and then you can feed that into SQL. Does that all make sense? Yep, brilliant. Now, this particular slide, don't worry, if you're not someone who's done lots of enterprise programming or done lots of JDBC programming, you might not have seen other kinds of connection pools. This one happens to be using an Apache connection pool library, but you might have some particular connection pool that's part of some framework. It might be Java EE framework or something that you're using. If you've got one of those, it's the same deal. You'll go and create your data source using whatever mechanisms are required for your particular connection pool or data source structure you've got, and just feed it in. It's pretty straightforward, same deal. Okay, now what about, we've now got a connection to the database, but I haven't shown you, we're not doing anything with it yet. So let's start playing with this database. If you've already got one created, so someone's gone and created an existing database and you're just trying to query it, you don't need to worry about these next slides yourselves. But I'm assuming, for my particular example, I've got a blank slate here. I've got no tables have been created, no data is inside them. So I'm going to populate a couple of things in there and then we're going to read it back. So just bear with me if you work in an environment where you never need to deal with this stuff. This is just some SQL that will create some tables. We'll create one table, it'll drop a table and create a table. We'll see other examples later on that create multiple tables. And all you need to do is, this is just a string. If you've never seen Groovy before, this is just a multi-line string. It's got some statements inside it. You just execute, using the SQL that we created earlier, you just execute and you pass in the string. Okay, it's pretty straightforward. And now we're going to insert a record. So this is a marathon runner from back in my youth who was getting world records in marathons. Back in the days where I still had aspirations that I could run fast, but before I realised I'm just a slow plodder. So this is just normal. If you've seen SQL before, there's nothing new here. This is just straight text in a string, and we're just going to feed that through. Oh, we're calling SQL.execute and passing in the string. So it's just going to add one row to the table we just created. Very straightforward. So it's about as simple as you can get if you're assuming that you're going to be exposing the SQL to the users of your library, which is what this particular library does. And we'll see later on with datasets that we can make the SQL disappear if we want. Okay, so this is showing you some different variations for inserting a few more records into that, few more rows into that table. So who's familiar with Groovy in the audience? Pretty much most of you. So you've heard what a Groovy string, a G string, if you've heard that concept before? Okay. So if you haven't heard of it before, this is in the earlier example, I just used some single quotes here. This is just going to have it's going to be treated as just a bunch of text characters. If it happens to be a double quoted string, or there's a couple of different variations, which I won't go into today, it's going to look for interpolated values. So it's going to be looking for this like $sign and looking for values that will be populated, interpolated at runtime. And I've got some data here that's in a map. And I'm going to execute the query, and I'm going to populate values into the query based on stuff that's coming out of the map. So this is the G-string variant of SQL.execute. Does that part make sense up to there? Now you might think, why would I bother doing that? Can't I just go and concatenate strings together? Well, if instead of coming out of this hard-coded map here, if this was actually coming out of a form from a database, and I was going to just concatenate the values out of that form into my query, does anyone see what a problem that might occur in that scenario? SQL injection, yeah. So if you've got a really smart user on the other end, they'll type in their name and then they'll start typing in bits of SQL, which might let them query or crash my database. So you don't want to do that, and JDBC provides a nice way of solving that problem by using prepared statements, which is what the example we're going to come up to next, which has got these little question marks. You would have seen that. You've been probably, if you're using this in an enterprise environment, you've been told use this variation. The nice thing about the G-string variant, it looks as if it's just going to splat data values in there, but it's actually using the prepared statement version under the covers. Okay, so it's auto doing all the right things to stop SQL injection. Yet you don't need to. It looks like something that's more readable and something that we would be happier seeing rather than this sort of stuff. Yes?
Can we use that parsed cursor too? It doesn't have to reparse the cursor every time.
Yeah. So there's with a prepared statement, I'm not going into the details of that, but it's easy enough to look up. It can become much more efficient, and for various scenarios, for repeated queries and for when you're using cursors stepping through rows as well. So all of that's happening underneath the covers. You don't need to worry about how it's working. So that's all nice and dandy. We're going to do another variant. If we want, we can do it the longhand way that you'd have to do in JDBC. You can feed in the question marks, and then there's a variant of execute. I'm going to show you I'm changing two things at once in this example here, which is a bit of poetic license on my part, but there's a whole bunch of variants of the execute method. There's one that takes a string, one that can take a G string. There's another one that takes a string which happens to have placeholders in it, as well as the parameters that will get fed into those placeholders. So all of those are variants of execute. All of those variants exist also for execute insert and for execute update as well. So the examples I'm showing you with G-strings and with parameter versions and with other things will work across all of the different statements. So here we're going to do an execute insert. We could have done an execute. The only advantage that execute insert does, when you're using execute, you can use any bit of SQL in here. When I'm using execute insert, I'm pretty much always going to use it. There's a couple of variations to do with stored procedures, but I'm pretty much going to use it when my SQL is about inserting. And what it does is, it's just a slight variation of the other method that will return in a list any generated keys. Okay? So you'd go and use execute insert if you happen to have some executed keys. And you might think, well, do I have that here? Do I need it? Well, it turns out that in this particular example, I decided rather than me having to populate some sort of ID, a unique ID for these athletes, rather than using maybe first name and last name as trying to get a unique key pair or something, I'm getting this particular database to generate the keys, okay? Now, depending on your database, the actual DDL you'd use can vary very slightly. Nice thing about standards, there's so many to choose from. Well, if you're using a different database, that line there might be different. Perhaps some other things might be very slightly different, but that'll be fairly common amongst the databases. So yes, in my example, if I am interested in this ID and I want to get it back straight away, I'm going the wrong way, that's why it's not coming up. Then I'll use execute insert, and that's returning the keys. Now in my case, there's only one key, right? If I happen to have a multi-row key, then it'll come back as a list of the generated things, okay? So in my case, there's only one of them, and it's actually going to, because this happens to be, my particular database starts off at 0 as the first key, then it goes 1, then it goes 2, nothing very imaginative. Because I've entered in, this is 0, that's the first athlete I entered in, this will be 1. This insert here, Ronaldo, will be the second key that gets generated. So again, if you go use a different database, the actual value that comes back might be a different number here. Okay, Now, when I executed this statement here, unlike in the earlier examples where I gave the date of birth, I forgot to do that when I was inserting Ronaldo here. So what I can do is update that row using an update statement from SQL. So here I'm going to do a SQL execute update. I can go and use execute if I want on that same bit of SQL, but if I'm interested in how many rows actually got updated, then I can use execute update and it'll return the number of rows. Okay? So if you're worried about what should I use, always go and use execute for all these statements unless you're interested in the keys that come back or unless you're interested in how many rows got updated. If you're not interested, just go use execute all the time. Okay? But these other ones are there if you need them. Execute insert, execute update. And again, there'll be variants for each of these: execute insert and execute update for a plain string, a G string, a string with parameters, and so forth. All those things will be taken care of. Yes?
You use the question mark notation. It just substitutes the string. There's not any injection, sanitization, or?
Yeah, correct. It does exactly what JDBC would do. And yeah, it's a fairly vanilla replacement that goes in. It stops any SQL injection because it's got a known type and it's getting plugged into a particular value. So if you've said that, or if it's expecting a string there, it doesn't matter if you've added extra SQL statements, it puts the whole thing as a string, as a varchar, as far when the database gets it. So there's no SQL injection can occur. So yeah, there's no magic, and yeah, we've thought about whether to try to do extra magic on the Groovy side. We've just, at the moment, left it all out because it actually gets quite tricky and is slightly different for different databases, and so we've stepped away from trying to do anything smart there. But you can do it yourself easily enough. Yep. Any other questions at this point?
Just something that you just said. So, this will bind those by the type. It'll match the type to the type of the column being updated. Will it know that? Like, at what point would you get an error by trying to update a numeric column with a string?
Yep. It gets caught at the database end, and then a runtime SQL exception will percolate all the way up. Now there are some experimental, so Groovy's recently had added static compilation. There are actually some experimental, well, I know I've done a play one, I didn't finish it, but I think other people have said that's a great idea, I'll go and do some more. I haven't followed them up to see if they did. But there are some now that will actually do extra. If you can use an annotation on your SQL here, and it'll actually go and query the database and do compile time rejection of your SQL statements if it doesn't match. If the types that you're feeding in don't match with what the database is expecting. But that's not in this library. That's a separate thing. That's just it's probably more a novel toy than something that's going to be always useful.
Sometimes where if you leave it up to the database to decide whether to do the type conversion, you could miss an index because it's going to convert the other side.
Yeah, there are some tricky cases. I'll show you. There is a tiny bit of stuff that Groovy does when we get to store procedures. When you can feed in the types, which handles the exact scenario you're talking about, but in a different context. Yeah, there's a few other cases where you could do some more things like that, but I'll show you that in a slide shortly. Okay, so yeah, when we execute an update, it tells us how many rows got updated. So indeed, for this particular example, it did find a row in there with the last name DaCosta, so it did update it, and update counts 1. Final example of updating. Hopefully down the back there you can see right down the bottom of this screen, it's fairly low. It's just a plain old execute with just a bunch of SQL in there. We're going to go and delete a row just for completeness. We've already done inserting and changing. We might as well do the full CRUD example there. Make sense? Yep. Okay, so that's putting stuff in. What about pulling stuff back out? Okay, so I'm going to show you a few different variants. Again, probably the trickiest thing with this library makes things very, very simple, but the part of the complexity of the library is, there seems to be lots of different variations. Like we saw there's an execute and an execute insert, execute update. Or when do I use which one? And I'll look, there's 7 variants of new instance. And it'll turn out, even though this library is very flexible and seems to be offering you lots of things, in your particular scenario, there'll be pretty much one of each of those things that'll make sense. So when you're doing a new instance, you'll have authorization on your database turned on, so you'll need the username, password, or a properties variant. And so even though there's lots of variations there to handling some edge cases, most of them won't be relevant to you. So it'll be fairly straightforward. Once you get the hang of it, you'll breeze through this stuff, and you become very, very efficient at pulling information in and out of databases. And you'll also find, if you happen to be dealing with JSON or XML or whatever, the kind of querying and iterating through the data that you're doing here, the Groovy code that you write will be almost identical to the kind of Groovy code you'll write to iterate through other kinds of collections as well. So when you're going through each row and stuff like that, there'll be similar, if not the same named things, there'll be very similarly named iteration style things that you'll be using. Okay, so let's start looking at some of the ways to pull stuff out of the database. The thinnest layer above JDBC that's provided is a thing called query. You probably won't end up using this very much, but if you happen to have very, very large result sets coming back, you can use this query version, and it'll let you, it's basically a very thin layer over result sets. It'll let you pull back a result set one at a time and call next, the kind of fairly low-level thing you do in Java. It's just a very thin layer above that. And so we can just loop around, printing out result sets. And these are the kind of things you'd be doing in JDBC, get string. We can do a column name variant or a ordinal index variant. But otherwise, it's a very, very simple thing. If it wasn't a string that we're pulling back, we've got to know what kind of type it is and get other things as well. Okay, so that's the lowest level. Most people tend not to use that, but it's there for completeness if you have very, very large sets or something like that. Most people move on to the ones I'm going to show you now. There'll be rows, each row, first row. They're the ones most people typically use. That adds a little bit more Groovy value add. So rather than having to deal with this get string 1, we'll use the same common notation that we'll use for other collection types, XML, JSON, and so on, using Groovy's compact syntax for getting at collections, the gpath information, if you've heard of that before. Only one tricky thing, the JDBC libraries use 1 as the first index value, and normalizing with everywhere else in Groovy, it uses 0 as the first index. So just apart from that little gotcha, you'll jump over to this and everything should work nicely. You can use either variation here. Okay, this little row that comes back is actually it's like a wrapped result set. It's a little map-like thing. So you can actually use it in lots of places where you'd expect maps, which Groovy's got lots of nice support for dealing with maps, so it's kind of handy. Just to show you so because I know it's a map, I used each row before. It'll actually be, this particular bit of code here will get executed once for each of the rows that gets returned. So if there happen to be 4 athletes in my database at this point, then this closure, the bit of code that's here, it'll get fed each of the rows, and I'll execute it. If I use first row, I'll just get the first row back. Okay, and I said before, and it'll be one of those. It's a wrapped mappy-like result set, one that's a bit friendlier to deal with. And because I know it's a map-like thing, I can use other things that I know happen to be in Groovy. There's a 2map string, for instance, and I'll convert that to lowercase, and this is what's coming back. Okay, I can pull back all the rows, and we'll see later on how to get paginated variations out of that. I can pull back all the rows, and that'll be a list of maps that I get back. So list of rows, list of records, right? And then I can go and iterate over those using each, collect, and all the other collection-like utilities that are available in Groovy. Yep. So in this particular case, I can go and get all my athletes and collect. What I'm going to do is gather the first name, and it's going to happen to be the last name. I'll explain this in a minute. Put it into a string, and then join them together. Oops, don't bump the VGA adapter. I've got all these examples here. I can run any of them if people are interested, but I'll keep going on my slides, and I might come back and we'll run some examples later on. Otherwise, I might find I'm running out of time towards the end. Okay, now what else haven't I told you? Has anyone noticed anything different about this particular variant here and what was on the earlier slide? So I'll jump back to the slide. I'm going to get the 0th column out of the row, and the column out of the row that happens to be last name. Now, I'm now going to use a bit of a G-string variant here, but the row that's coming back, which IT is the default closure parameter, so it's the same as my row. If I don't want to give a name to my closure parameter row here, it'll just default to it, the iteration value. It's like this. Those who don't know Groovy, most of you did, but any differences there compared to earlier? Uppercase. So it's a Groovy-friendly map, but it's got a few little tweaks to deal with the SQL world. In SQL, most databases normalize keys to uppercase, but not all of them do. So anyway, to cut a long story short, under the covers, the map that's getting produced is one that's case insensitive on the key. Okay, so I can call lowercase first name, uppercase, or any combination of the key value there, and it'll work. The only other thing that's happened here is Groovy's collection libraries let you start counting from the right-hand side instead of from the left-hand side. So instead of being the 0th row starting from the left, if I use -1, -2, -3, it's from the right-hand side. So -1's the last from the right, -2 would be the second last from the right, and so on. Okay, so this will go and get the last row, that it'll happen to be last name as well as first name here. Okay, and then we're just going to join them. So that's just going to be the names of my athletes with commas between them. Okay, and you can go and get, if you're not getting result sets back, but just some sort of calculation that's scalar values or what have you, you can do count star or whatever, give it as num, and it'll come back as a result set-like looking thing that happens to have a num value, and which will be the number of rows that happen to be in my table at this point in time. Does that make sense? Yep. Cool. Okay, so want to show you some examples of invoking stored procedures. To give you some more meaningful examples of stored procedures, we're going to throw in another table and a few indexes and things. Don't be too worried about the details on this slide. This is the table we had before, the athlete. We've got another table which is now a run, so this will be a marathon run. We're going to put in the distance, which always happens to be the same value for marathons, but anyway, and when it was run and who the athlete was and so on. Okay, so that's some information. There's some index stuff there, but don't be too concerned about that. That's just how this particular database wants things to exist to make foreign key access efficient. And so what I've done is I've created myself a little helper method, insert athlete and insert run, that just has the execute inserts that we saw before. I've just embedded that in a little helper method, and we're just going to fill it with some rows. Okay, that's just to show you that I'm not cheating. I've got some real data there. And so we're now going to start feeding in cities and times and so forth, feeding those into the database. 2 hours, 5 minutes, and 38 seconds, and so on. These all happen to be world records at the time, but anyhow. Now what I'm going to do is create a stored procedure. Now again, this is like the DDL. I said there's some slight variations in DDL across the different databases, depending on which particular database you're using. Stored procedures is another area where, unfortunately, even though the concept is very familiar across all the databases, some of the details in stored procedures will be slightly different. Groovy doesn't try to make creating the stored procedure, doesn't try to make that part any more normalized than JDBC does or SQL does. What it tries to do is make the access to that, invoking the stored procedure as friendly as any other select type statement. Okay, so we'll come back and look at how you use it. So again, if you're in an environment where someone else is creating the stored procedures for you, just ignore all that part of the slide. Someone else will go and do that, and you just need to access it here. Now this particular one is just trying to save us, rather than us writing complicated SQL that's spanning, dealing with multiple tables, might have joins or whatever in general. Rather than us having to do that, this just happens to be a little stored procedure that's going to pull back athlete and run information all in one go. Okay? So we're going to call our function here. This one happens to, for simplicity of this particular, as the first example, doesn't take any parameters. It's going to return all the runs for all the athletes in the table. Okay? So if I've got no parameters, and parameters will be dealt with, well, there's a few different variations, but for most of the simple cases that are returning tables, we can use any of the methods we saw before, each row, rows, and so on. Okay? The complicated stuff that's happening as far as the stored procedure is concerned is irrelevant. It's just coming back as a result set's coming back. So we can ignore the fact how it's coming back. It's returning a table, a result set. So we just use all the things we saw before. We can go use the query one if we want, the each row, first row, rows, and deal with it as we saw before, and we just pass in calling the stored procedure here. Okay. Okay, then we're just going to print out last name, venue, and when it was run, and we'll get information coming out. Does that make sense? Yeah, so this is the simple case. Let's have a look at what if you've got, so some functions can return scalar values, some can return scalar values and result sets, some will take parameters and so on. So this is where stored procedures start getting a bit more complicated. The good news is all of that's taken care of. You've just got to become a bit familiar with how it's invoked. So here's another function. Again, the details of what's going on inside here aren't important. It happens to take one parameter and return a scalar value. So you use a special syntax here, which is JDBC's placeholder syntax that we saw before. Put a question mark if it's going to return a value. That's going to handle this bit. And if it takes a parameter, which is what the last name bit up here is, you put another question mark as a placeholder. Again, you can use the G-string variant to handle this particular one if you want. And then you feed in your parameters like we saw before, so that's going to go in as last name. And it'll come back as a result set looking thing. It happens to only have one thing in it, which happens to be the first name concatenated with a blank space concatenated with the last name, but that's kind of irrelevant, but you can see that's what's got spat out at the end. Yep. And if you've got more complicated examples, then the way JDBC allows you to handle this, and this gets back to some typing questions that were asked earlier, this particular example has an out parameter, an in parameter, and another in parameter. So it's got one out and two ins. In general, you might have any number of outs, any number of ins, any number of in-out parameters. Something can come in and out. And when we're going to call this stored procedure, it's not returning any value, but it's going to produce a result set. And so we don't need the question mark bit here, but here's the three parameters, the out and the in-out ones. For the in ones, we just feed them in, like we've seen before. So there's the two in ones that we're feeding in. For the out one, SQL provides the ability, there's not enough information without going and querying the database to know what the type that SQL is going to be expecting here. So in the SQL library, there's the ability to specify what kind of type it is here, and the right kind of matching happens underneath the covers for you. So here the output parameter is going to be a varchar. We can feed that in as a type, and everything will be happy. Does that kind of make sense? So you can get quite complex scenarios. The nice thing is, by the time we get to here, it's apart from this slight variation of feeding in output type information, it's very, very similar to what we saw before. So we've got placeholders, feeding in some information, and we get stuff back. If you want to have this magic happening with the out or in-out parameters getting married up, you have to use a call. So it's not good enough at this point to try to use the first row or rows or any of those other ones. If we want this magic to happen, it's a call variation. There's a few variations on that, and it'll for each row that comes back, it'll invoke this particular bit of logic. In our case, it's only going to match. It's only going to find one. In fact, this is not even querying the database. It's just concatenating bits of inputs together. But if in general you'd be querying the database, then you might have multiple. This might get called multiple times. Okay, so that's all the basic reading and writing done. I wanted to show you some slightly more advanced examples. Now, one of the things you can do, and you'll be familiar with this if you've done sort of advanced JDBC stuff, you'll have seen how to get access to metadata. Now, there's only one little tiny tricky bit in this particular slide. And remember I said this thing came back, it's a sort of Groovy-friendly wrapped result set. So it's actually a mappy-like thing. Normally in Groovy, you can use, instead of typing .get metadata as a method call here, I can leave off the get, have a lowercase m, and leave off the brackets, and it's a property access. If you try to do that in this particular example, it'll go and look for that as a column in your database. So you can't use the shorthand in this particular scenario. There's only a very small number of places. There's a get class and a few other little get class in maps and a few other little places where this little gotcha comes out. So just be aware of that one. Apart from that, this is the same kind of code you would see if you were doing this from JDBC world on a result set, even though it's our friendly result set. So we can go and we're doing select star from our database, and we're going to go and get the metadata, and that's going to let us get to access like things, how many columns are there, what are the column labels, and that sort of information. There's other information that you can get as well. For our purposes, that's all I'm going to be looking at, labels and counts. And we're going to print those out. So this little bit of code here lets us dump out a table in the database like that. I'm actually cheating here. This is, I'm going to show you a slight variation. This is actually the output from the next version of this slide I'm going to show you, but it doesn't fit on the slide. So I'm cheating a little bit, but I'm making assumptions in this one that all my columns are going to fit in character size 40. That's more than 40 I'm showing you there, but bear with me, I'll show you the real version for this. So this one here is using the version of each row we saw earlier. So the one that just, in fact, I'm doing the bad SQL injection potentially here, but table name isn't going to be coming out of a web form, I hope. Hopefully you don't let your users type in the tables they want to query. So this is just the variation that takes a string and then has a closure which is going to work on it. So anywhere where I've got one of my friendly row results, I can go get the metadata. I just wanted to show you that. But most people who want to access metadata, there's a special version of each row and rows and all the other methods that takes an extra parameter. So instead of just having one closure that runs a bit of code from here to here, it's going to take two closures. One that gets executed just on the metadata and one that gets executed for each row. So I don't need to go and I don't need to know about this nasty little trick that we had here. So let's have a look at that variation. That happens to be the variation that printed this out, but yeah, just bear with me. Okay, so here we go. We're going going to define one closure, which is this bit here. This is going to be the bit that deals with handling our metadata. So it's a closure, and it gets past that metadata. I don't need to worry about doing the get metadata anymore. And this closure here is the one that's going to print out each of the rows. Okay, so just these 3 or 4 lines here. Then when I call each row, I'll do my table name as before, and I'll pass in the 2 closures as the results. So I'm not using the compact syntax we saw here, where in Groovy, those of you who are not familiar with Groovy, if the last parameter of a method call is a closure, then you usually use this round bracket syntax, putting it afterwards. In fact, all that's just a closure that happens to be the second parameter to each row. Okay. In this particular variant, it usually looks nicer just to pass in the 2 closures just like that. Does that make sense? Yeah. Okay. So that's some advanced reading stuff here. If you've got large sets of data and you might be presenting information, a shopping cart or a shopping catalog to users, and you want to give them 20 or 5 or 20 or whatever rows at a time, there's a ability to pass in the first row and the number of rows you want to get back. Okay. So when I call rows, passing in my query, I can give the starting row that I'm interested in and how many rows I'm interested in. So this will be paginating through my rows. So I'll get back each one of these. I'm getting back, because I'm getting back the friendly row result set thing, the mappy thing, and I'm going to just pull the last name out of each of those. So there's the first 4 records. I've populated this database with a bit more information. So I'm going to start at number 5 and then pull out 4 records. And here I'm going to start at number 9 and try to pull out 4 records. There's only 2 left, so it'll just give me those. So you can use this to paginate through records as well. Does that make sense?
Yeah. Does that assume then that when you want to start on 9, that it's still going to fetch and do the pagination after it's fetched the whole result set?
Yep. So there is JDBC calls that let you set the first row and the max rows, and Groovy is just setting those. So it's up to so the question was, what's happening under the covers? Is there some tricky caching or everything going on? In fact, depending on your driver, there can be some caching going on, but it's not guaranteed by the JDBC spec. The JDBC spec just says, you can set the first row, you can set the last row, and depending on what happens underneath the covers, there might be some smart pre-fetching of rows or not. It's up to the JDBC driver, and you might need to go and switch on some driver features to do pre-fetching and stuff like that. Okay, so Groovy stays out of that and lets you'll have to go and look up the doco of your driver if you're wanting to do anything. Okay, so if your driver is really dumb, it might actually go and load all, what do we have, 10, 442? Yeah, 10 rows. It might go and load all 10 and then throw 6 away, load all 10, throw 6 away, load all 10, throw the first 8 away. Or it might be doing smart prefetching and optimizing as you go. Okay, so that's pretty much all I wanted to cover in terms of advanced reading. Advanced writing, you can use transactions. So you can go SQL.with transaction, and then inside here you can use any of the execute inserts, execute updates, deletes, and the stuff that we saw before happening. You can put any of your CRUD operations inside the SQL.with transaction, and all of that will be done transactionally. So that'll turn off the auto commit type thing you might be familiar with, do all your bits of stuff, and then do a commit. So it's pretty simple to do transactions. Yep. Only across one particular database. So this won't do a transaction that bridges Oracle and MySQL or anything like that. But within one, it'll do across tables and everything inside Oracle or whatever. So very, very simple for handling all the simple cases. You can batch statements. Okay, now there's 2 variations of batching. Remember before we had talked about I didn't really talk about. So if you're wanting to know about JDBC, I would have started explaining to you what a result set was, what a statement was, what a prepared statement was. You might have noticed that a lot of that is hidden underneath the covers with a little bit leaking out in that, oh, okay, we saw some placeholders. Yeah, there's a prepared statement underneath there. Oh, there's a G-string variant. There's a prepared statement under there. For most of the time, all of that gets hidden away and you don't need to know about that. For when you're doing batching, turns out that it does percolate a little bit to the surface. So if I just use SQL.withBatch, I'll be given a plain old statement at the JDBC level, and I can just do add batch and put some SQL in here. Okay, you won't get any of the fancy sort of optimizations you'd get out of a prepared statement in this scenario, but you will get some batching depending on how your driver handles batching. Okay. Normally, when you want to do batching, here I'm just doing some arbitrary blats of SQL, and I'm batching them together. Normally, the time you want to use batching is when you've got mega amounts of data and you're pumping lots of rows into a table. That's the more normal scenario. This is just to show you that we can handle arbitrary stuff as well. So the next slide shows you the normal scenario. And here, we want to insert a whole bunch of rows into Athlete. And I'll have a query here. And if I feed in a batch size as well as a query, I'll now have a prepared statement. On the prepared statement, I can do add batch, and I just basically pass in the parameters for each one. So this is the normal case of batching when you're using Groovy. And it's using prepared statements underneath the covers. If I didn't label this PS, and it's called a statement or something, you wouldn't even need to know. But the syntax for prepared statements and non-prepared statements is slightly different. So when I'm calling, actually no, this with batch can also take a statement, but the add batch here, instead of it being a blob of SQL, in the normal case, it'll just be all the parameters. Yep. So these are the parameters that'll get fed in there. This can be a G-string variation as well. You could have $ first name, $ last name, $ date of birth, or whatever. Yep. Now, because I set a batch size, there's a default batch size. Because I set a batch size of 3 here, and I'm trying to pipe in 5 records, if you go to and you're logging on and see what's actually happening at your database, you'll see 3 of the rows got blatted in, and then 2 more rows got blatted in, right? So because I've done a batch size of 3, it'll try to chunk it in 3s. It happens to the last one will be smaller, ran out of data. Make sense? Yeah. So you can start writing really, really efficient population of databases. Normally, you're not going to have a batch size of 3. You'll want to enter 10,000 rows, and you'll have a batch size of 100 or something like that. And so you'll be blatting it in at a very efficient pace. Okay, so the final thing that I wanted to cover we're still at the low level. We want to move on to some of the higher level stuff. Is a few different variations that were mostly added in for users that were calling the SQL libraries from Java. So if you're calling the SQL libraries from Java, you're not going to have the G-string syntax and so on. And you can go and create G-strings in Java, but it's a laborious manual process that you need to go and populate fragments of strings and populate parameters. And it probably would be more complicated than just using the JDBC libraries directly. So what we wanted to do was provide a way in which people in the Java world can achieve similar things to what the G-string was going to give you. And basically, instead of having $ first name, you can have colon first, colon last, and so on as the placeholders. Okay, now this isn't a syntax that was invented up by Groovy. It's actually used by several other database frameworks that are around. Happens to be one from IBM that this is sort of closely modeled on. But there's named parameters there's ordinal parameters and named ordinal parameters. So there's a few different variations. Let's have a look at the different possibilities that are here. Now again, so this is under advanced. If you're using Groovy, just go use the G strings. You probably won't ever need to use this. But just for completeness, I wanted to show you that these things are supported by all of the libraries. And I'm going to just show it to you with, I'm going to be doing a executes here, but this particular syntax will be work on rows and all the other things as well. So it works across all the different methods. So let's have a look. We're going to create ourselves a domain object. So canonical class athlete, first, last, and date of birth. So it's a little domain object, and we're going to create some of these. So I've got one athlete here. I've got another athlete. This particular athlete, I didn't fill in the date of birth. I happen to have that in a map. Okay, and then I've got just a straight map, someone's information just in a plain old map. And what the different variations here, they're all just normal executes, and they're all going to start off with this chunk of text, but because it wouldn't fit on the slide, I've gone and created a little prefix here. So imagine all of that at the front of here. The only bit that's changed is this conglomerate of stuff over here. So what are the different variations that I can have? If I've got a single parameter over here, then this parameter can be a domain object or a map. And if I go question mark dot first, it goes to that domain object and looks for the first key in a map or the first property on a domain object. Yep, pretty straightforward. If I go question mark dot last, it again goes to my parameter object here and tries to get the last property of that object. Similarly, date of birth. Yep. If the whole thing was a map, it'll still work. Okay. I'm going to skip this line. I'm going to jump down to here. That can be a domain object or a map. This can be a domain object or a map. So just as an alternative syntax, if you don't like the question mark dot, it supports colon and the names as well. And again, this is borrowed from other libraries that use this particular syntax. And this is fully trivially easy, because these are just strings, trivially easy to call from Java if you needed ever to do that. So I can call colon first, colon last, colon date of birth. And just to complete the scenarios here, Groovy's named syntax form, if I go first colon and last colon and date of birth colon as the parameters, it automatically puts all those into a map. So you can put the whole thing all in this sort of syntax and not have any of these helper objects as well if you really wanted to. Make sense? Yep. Now, if you've got named ordinal parameters, which is the last variant I haven't shown you yet, this is when you've got multiple domain objects you want to pull stuff out of. So in this particular case, remember, I arbitrarily decided that, we're not going to put the date of birth in initially. That happens to be residing over somewhere else in a map. So I can have any combination of domain objects and maps also, and in fact name parameters if I wanted to. They would all, if I had the name parameters, that would be all of those would be under the first parameter, and everything else would be bumped along one. But that's more complicated than you'd need. So if I go question mark 1 dot first, it just goes to my first parameter, which happens to be this domain object, and it's pulling out first and last name. And the question mark 2 goes to the second parameter, which happens to be the map here. Either one could be either or, and pulls that out. Does that make sense? Yep. So again, word of warning, this is sort of advanced stuff it was really done to make life easy for Java developers that were wanting to leverage some of the features of Groovy, but it was also wanting to, this all came about in the lightweight alternatives to Rails sort of community. Other libraries were coming with this exact same syntax, and Groovy was just wanting to support that. People coming from using those other frameworks would be familiar with this syntax straight away. So this is it comes from other places. Okay, so that was diving through a whole bunch of layers of groovy.sql.sql. Now going to talk about datasets. I'm going to try to do it without getting too complicated, But the first thing I'm going to show you is a big complicated bit of DDL. Same as the one we saw before. It's got an athlete table and a row table, so I've made that light. You don't need to worry. The only thing that I added here is a view. So this particular table supports views, and that'll be relevant towards the end. Don't be too worried about the details there. In fact, I've got it all on the next slide here. So I'm doing data sets in one slide. If you go and look at the definition of data set, it just extends SQL. And what it does is it makes all the row result sets and the querying and everything look like normal Groovy collections. So it uses GPath-like syntax. Okay, so you'll see there's no SQL on this slide. Okay, I'm going and there's a factory method on SQL, the same SQL we saw before. You just go .dataset, put in the table name, and it'll now, when you do these statements, when you're doing each and when you're querying with find all and so on, it'll come back instead of obviously being a row result set, you think of it as rows in a collection, okay? And use normal GPath-like syntax. So if I just go athlete, SQL.dataset athlete, it'll be the same as doing select star on that athlete. If I did find all or if I just go each, it'll be all of the rows. So I can print out all of my athletes' first names. Athletes.each, printline it.first name. Now that's, if I had all of that data in memory in a collection, or I had it in XML, or I had it in JSON or whatever, the code to iterate through it would look identical to that. Okay, so it's a really nice way to remove the SQL from the scene altogether. If I want to add a new row, I can go use the add method, athletes.add, and I can add those in. There's again a couple of variations on that, but this will do for us for now. It'll automatically match the keys here to the column names. Yep. Again, it'll be case insensitive. So this will add a new row to the database. If I now go and print out each of the rows, there'll be an additional first name in my list. So that if there was 3 rows, there'll now be 4 rows. Make sense? Yep. Now what's happening underneath the covers? Basically, when I do the each here, it'll be select star. When I do the add, it'll be the execute insert. When I do the each here, it'll be another select star. Okay? But I don't see any of that. That's all happening underneath the covers. There's some smart stuff happening, which I'm going to explain on the next slide as well. In fact, I tried to shrink this all down on one side. I probably shrunk it one bit too more than I wanted to, but anyhow. Let's go and look at how you'd, rather than getting all the rows, we want to find some particular ones. So I can go queries, athletes.findAll. I can find the date of birth is greater than some value, and the first name equals Paula. If I now print out the results of this query, if I print out each of the things that came back, it's only going to have there's only one athlete with first name Paula in my data set. It'll print out one athlete here. Just to show you what's actually happening underneath the covers, remember I said here it was like a select star. If you do a find all, then it'll be a select star where, and it'll have date of birth is greater than that and first name equals Paula. So you'll have and it'll be a prepared statement as well, so you'll have placeholders. So I can actually go to this query object and print out the SQL that would execute if I actually tried to use it at that point. And I can also print out the parameters, so I can see the bits of values that'll get substituted for the placeholders. So you can actually see what it's going to do. Now the nice thing is, it's actually lazily evaluated. Now I've shrunk this just one line more than I actually wanted to. If I took this query and did another find all, maybe I could do 3 or 4 lines. Find all the athletes born before 1970. Now find all the ones who've run in London. Now find all the ones who actually won, some sort of query that built that up. And then I said, now print them all out. What you'd find if you turn logging on to the database, a single query goes to the database that actually combines all of this information. Because it's lazily evaluated, if I don't actually go and use the results, it just says, oh, yeah, okay, I'm remembering that you actually want to refine your result further. It remembers all of that. And when you actually go and try to use, now print out the result, or store the result, or whatever you're going to do, that's when a single query will go to the database that actually concatenates all the bits of the query together. So it's super efficient, NoSQL anywhere. All right? Lazily evaluated if the user's browsing your website and they go away before they've actually finished doing anything, they never bothered printing out any results, whatever, you've never hit your database at all. Yep. Make sense? Okay, I wanted to actually refine my query there, but I've just given you an example similar to the final one there is similar to that. It's just showing an example where multiple rows come back. This particular athlete had 2 runs, so it's just showing you that I can use each on results of queries rather than just getting single ones. Well, I've used each there even though there was a single one. Okay, so that's datasets. It's fairly straightforward. Oh, no, that's not what I'm showing you in the last one. So if you like, datasets are a mini ORM. So I don't need to go and get Hibernate or anything like that. Hibernate is an alternative. There are other, if I'm using a relational database, there are other fancier ways I can go and not have to deal with SQL. I might have to deal with HQL or something else. But this is a mini ORM, if you like, an object relational management thing that simplifies or hides away the SQL. But it only works, datasets only work on a single table. So it's only athlete, or only, I can't, in my find all queries here, I can't go and mix the athlete table with the run table. But I can work on views, which was the view that we created earlier on. Okay, that's what I wanted to show you in the last one. So here, I've gone and created a view athlete run that actually just combines, it does an outer join on the 2 tables there. I can use datasets on those views, and it's quite happy with that. So again, I can stretch what this mini ORM will do for me a little bit further. If you need beyond what we've seen here, it is a fairly simple framework. That's when you need to go and look at Hibernate, or there's a whole bunch of other variations these days as well. It makes sense? Yep. So I could go and, you could spend much more time diving into datasets, but it really is a very simple concept, and I didn't want to overcomplicate it. Okay. Now, yeah, question. Yep. Yeah, so yeah, there's probably one other bit of information I probably should have included on this slide that would have made it a bit more complete. As well as doing find alls, I can do .sort. So in Groovy, I could do sort things, and that'll, if you do, when you're doing find alls, if this ampersand will get turned, the double and ampersand, the logical operator in Groovy will get turned into an and in SQL. The sort, if you go .sort on the query that comes back here, if you did .sort and said sort by date of birth or something, that'll go into an order by. Okay? There's no .group by, but there is group by in some collection libraries you could use, but that's happening that's not going to do fancy SQL. It's going to be done at the collection level. Yep. Okay, so so far this has been databases that are relational databases, so they're highly normalized, and it's for dealing with data that's where you typically have large volumes of data, but the relationships between the different rows in your data tends to be less interesting. If you've got data like friends on Facebook or Twitter or something, and you want to know friends of friends and friends of friends of friends and things like that, very, very quickly, in scenarios like that, you'll find that the relational database paradigm becomes much, much less efficient. Now, to be honest, I'd probably say still 90% of my customers are still using relational. So I don't want to overemphasize the need to move away from relational. But if you're in a scenario where you've got particular kind of data that's graph-oriented or document-oriented, which is what these ones are going to look at, the moving to a framework like MongoDB or Neo4j will just make your life so much easier for dealing with those scenarios. Now, if you've got small volumes of data or whatever, it probably doesn't matter which one you use. So it's not going to make a difference. So it's worthwhile going and learning about some document-oriented or graph-oriented databases. But I'm not going to try to sell you that every single one in this room should definitely go and use a document database or go and use a graph database. I like to have lots of things in my toolbox, and I really love having those options in my toolbox, but quite often I'm still going back to relational databases in my toolbox as well. So it's kind of nice to have all the options available to me. So what I want to go is use MongoDB. So it's a document-oriented style database. So rather than a database where you've normalized all your data into lots and lots of rows, and then you have other tables and indexes in your rows, you basically keep blobs of related data together in documents. Okay? If your data is structured that way, this kind of database is really, really handy. We're going to go and look at the athletes example. Now, heck, I've only been looking at small numbers, 10, 20 athletes, 30 to 50 runs. It's not going to matter which of these frameworks I go and use. They're all going to perform quite efficiently. They're all going to be suitable. But we'll see some nice things that come about because of using these different paradigms. We'll see a little bit of that. So I'm going to use MongoDB as my database. There's no built-in MongoDB in Groovy or anything, so you've got to go and download the server and whatever, or be in an environment that has a server. And you also have to go and get a driver to talk to that server. And there happens to be a GMongo library, which is some Groovy value add on top of there's Java libraries and things that are available for MongoDB as well. It's written in C++, I'm pretty sure. Yeah, it is. And this happens to be a library that you can use from Java or this one's Groovy for accessing that database. Don't be too if you've never seen the field thing in Groovy, this is just a way to make allow me to use this in methods. Did I actually use any methods in these? I do use some methods. Don't worry about this detail here. This is just allowing this database variable here to be accessed in some method calls later on. So what I need to do is using a factory method that's part of the GMongo library that I'm going to be using. Go and get a particular database that I'm interested in. Okay, I'm going to go and clear it all out in this example. Otherwise, every time I run this, it'll more blobs of data, more documents are going to be stashed away in there. So I'm just going to go and get rid of them all. Then we're going to populate it with some data. Okay, and it happens to have nice little operators that Groovy supports for going and populating information. And you can see here that we're adding maps of data. But if we have, if the data values that we're feeding in are also maps, then we actually get documents pointing to documents automatically. So all that foreign key stuff that we were looking at before, that disappears here as long as you're understanding what's going on in your head, and that'll become important if you want to go and query this later on, understanding what the relationships are between your blobs of data. Yes?
So how do we connect to the NoSQL database? Is it like same tribal manager, or
this is all you need. That will connect to the database there. Yep. Okay, so that's how you do it, feeding some data directly in. I'm going to create myself some little helper methods. You know, we used insert athlete and insert run, just showing you how you could write those. So insert an athlete just feeds in a map-like structure of data. Insert run, we actually want to go and pull out, we want to go and find the document of a particular runner and update it by putting in more blobs of other documents into it. So we actually do an update, we feed in how to go find the document blob that I'm going to update, and then there's a special notation that's basically saying, yeah, add some more documents. It happens to be the runs that this particular athlete has run. We're going to add those in, and again, they're just in map-like syntax. Does it all make sense? Pretty straightforward. And then we can go and basically use insert athlete and insert run as we saw before, and nothing else changes. Okay, so this is a special known key that the GMongo library, and in fact Mongo knows about, and it'll feed stuff in. Yep. Now, if you don't like dealing with, so this is all in just Groovy's literal map-like syntax. If you happen to have data that's already in JSON format, so this is a JSON formatted string, just this whole big thing's just a string, and inside it it's JSON formatted, then I can just go to my athletes and just pass in a whole blob as a document, and it'll take that format as well. Does that make sense? Yeah, so pretty trivial to deal with. Now we can go, because I added one athlete manually, 2 using insert athlete, 1 using JSON, we should have 4 athletes in my database now. Okay, so I can go to athletes and get the count of documents. So they're the big blobs, which are the athletes. If I want to, I can go down and see how many runs a particular athlete, in our case, all of the athletes, how many runs I've got in my database. So here's my 4 athletes. I've got 3 runs there, and another run as part of the JSON. And I'm missing, I must have done them manually somewhere as well. Oh yeah, there's a run done manually in the first one, so I've got 5 runs. So the first athlete's got 1, the second's got 2, 1 and 1. So there's my 5 runs, and I'm just printing all of those out. So this syntax, it'll look like, it shouldn't be too dissimilar. There's some, again, a little bit of magic, and by convention, there's a way of getting to the ID. If you go and run this, you'll get different IDs. This happens to be what came out in the run I did. If you go and run this example yourself, you'll get a different unique identifier there. Okay, so we can now go and do various kinds of querying and aggregating on that data. And again, it'll be a sort of a JSON-like format, or a map-like format that we feed stuff in. So we can go to the athletes, find all the runs that happen to have the venue London. So that when it looks through all the runs and see which ones, all the athletes that happen to have a run in London, and then just print out their first name. So both Khalid and Paula ran in London. We can find all of the young athletes. So we can go and do various aggregation type operators and feed in various operators, matching certain things, sorting in certain orders and so on, and feed those in and print out the first names. And so this will be all of the runners who were born after a certain date in sorted order. Okay, so these are the young runners in sorted order. So Paul is the youngest and so forth. Does that make sense? Yep. Now you can go and find out what the different queries are, but just looking at the Mongo documentation, it's fairly straightforward. So what I want to do now is flip over. So that's, if you've got data that happens to be in this blobby sort of structure, it can turn out that accessing it this way is very, very efficient, and depending on how you need to scale this data, it can scale really, really nicely as well. Neo4j is a graph database. So it's similar sort of idea in that we don't want to go and jam-pack everything down into normalized rows, but we'd go use a graph database when the information that we're interested in is actually about the relationships between the blobs. So here I've got some athletes, here I've got some runs that they might have been in, and it turns out that these athletes won these particular marathons, but also they won them in world record time. And as they were moving down in time, the world records got broken. So if we're interested in now finding out information that's looking at, so we're interested in the vertices, which is our blobs, and the edges of our graph. If we're interested in doing queries on that kind of data structure, graph databases come into their own. Okay, if you go and listen to one of the people who are selling you on this style of database, and they'll give you the performance stats. You can very, very easily come up with perhaps usual, perhaps unusual queries. I'm not really an expert in having billions of rows of data to trial this on, but the stats that they can produce show that queries that will take literally days or months can be milliseconds if you've got this sort of graph information as part of the structure of your underlying database. So that's the kind of thing we're interested in. I'm not going to go into too much of the details. The code here is a little bit longer than what you might like, but there's more work happening on to Groovyify this code. So a whole bunch of inputs there. We're not too concerned about that. What I've gone and done is I'm using a Java-flavored library, and I didn't like the conciseness that it gave me, so I'm using some metaprogramming in Groovy. Now, I don't want to give you a tutorial on metaprogramming today. We're going to run out of time, but what I'm going to do is add things like create node to the database class, add things like property missing and method missing things to the node when I pull back nodes, and try to access properties or call methods on them. If they're not found, it'll go and set properties and get properties on the underlying node. This is just going to allow me to have nice, compact, groovy syntax. So there are some value adds we've added. My understanding, I didn't get a chance to look. My understanding is that some people in the Neo4j community have been poking this stuff away in some libraries to make it more Groovy friendly, but I haven't had time to play. That might disappear. I'm now creating some helper methods. You know how we had insert athlete and insert run? Okay, in a graph database, if I want to insert an athlete, I'm going to create a node and fill it with stuff. When I want to insert a run, I'm going to create a node again, but I'm going to populate, and this is going to use some of my the meta class magic I had on the previous one. What I want to say is this particular athlete ran this particular run. So ran here will be a edge that I'm interested in. Okay, so I go and do that. Then I can go and do the insert updates and insert runs that we saw before. I'm going to have to, there's a little bit of magic I need to do there's questions asked before, how do you set up and get started? This is some stuff to do it. I'm going to use Gremlin later on, but normally you wouldn't need to see that for the first bit of code we're going to show you. You're just going to go graph to be beginner transaction. And I'm going to populate some objects here because that's going to be relevant. I'm going to just create nodes and again using some meta programming magic. Athlete 1's first name is this, athlete 1's last name is this, and so on. That's going to start populating the nodes that I'm creating. I'm going to create some runs or marathons. I'm going to say particular athletes run. So this is doing it all manually. And from then on, I'm going to use the helper methods that I used before. I just wanted to show the longhand way as well. We're going to now fill it. And pulling some information out. So once you've gone, these are all vertices in my graph database that I've got access to as objects. I can go to Marathon Run or Run 1 and get the venue and so on. But the reason why I'd go and put all this stuff in this graph database is to do relationships. And this is the kind of graph, this is the kind of thing you can do. So what you want to do here is, if I want to find all the athletes, these are all the athletes here. What I want to do is find all the athletes, so get all the athletes, find all the ones where an athlete has a relationship, which is, so there's an edge named ran, and any edge named ran that happens to point to another node in my graph where the venue was London. Okay, so I can now start doing this kind of thing. It looks a bit long and verbose here, but it's actually very, very powerful. I can be jumping all the way through this graph data by saying, yeah, I want to go find me someone who's ran here or where someone else was also running who happened to also be here so I can be jumping around in arbitrary complex ways across this data, and it'll be very, very efficient. In a relational database, it'll be very inefficient to follow this sort of data through. Now I'm going to add some more. Remember that I talked about world records that got superseded. I can add in more edges to my graph. Well, that's just showing the result of my query, one in London. And now what I want to do is find all world records that were broken following a record that was broken in London. So again, this is if you've got this kind of rich graph-like data, you can start doing all sorts of things here. So I want to do a breadth-first search, looking for where world records are broken. That's the supersedes, only going down to depth of 1. So I want it to be the run immediately after a run in London that broke a record, and so on. You can start traversing this in different ways, having different kinds of uniqueness constraints, all sorts of weird and wonderful things here, and that'll print out the list of records. I'll get a bunch of paths, which is paths to blobs, and that'll print them all out. The last thing I'm going to show you, or almost last thing, is there's a thing called Gremlin, which gives you a more compact syntax. So instead of seeing all of this stuff, you can just see edges and vertices with V's and E's and things like that in a nice little compact syntax. So here we can just say, yeah, give me the ones where the venue was London and fill in this set of results here. And here's the ones where the venue in London supersedes, all the ones in London where there's a supersedes relationship, which means it must have been broken, and fill in a result set. So Gremlin is a little Groovy DSL, if you like, for doing nice, compact, rich queries on graph databases. And yeah, here's we're going to loop through looking for. I'm just going to show you some fancier stuff with Gremlin, looking for particular records that which world record superseded the Berlin world record, basically. So you can see the kind of thing that you want to do there. Okay, that was a whirlwind tour of different kinds of relational databases. More details are in Groovy in Action, which should be out soon, which is probably what I said last year, but this time I'm hoping that it's true. It's going to be my main priority after a little bit of conferencing and stuff that I'm doing right now. Okay, I think we're just out of time, but is there any quick questions, or otherwise come and see me afterwards? Any quick questions? Or okay, we're out of time. We'll call it quits. Come and see me. I'll be around for the whole conference. So if you've got any more queries, very much happy to come and talk to you. Thank you.